Hey space enthusiasts! Today we've got some exciting news about Jupiter's Great Red Spot. This massive storm, the biggest in our solar system, is shrinking, and a new study might help us understand why. Located in Jupiter's southern hemisphere, the Great Red Spot is a swirling, red-orange oval of high pressure that's over 10,000 miles wide. It consistently blows more than 200 miles per hour in a counterclockwise direction, making it technically an anticyclone. This iconic storm has been shrinking for almost a century, especially over the past 50 years. While its width has stayed relatively consistent, its length has shrunk from 40 degrees in the late 19th century to just 14 degrees in 2016, when NASA's Juno spacecraft started orbiting Jupiter. Caleb Keaveney, a PhD student at Yale, and the lead author of a new study in the journal Icarus, says, "Many people have looked at the Great Red Spot over the last 200 years and were as fascinated by it as I am. A lot of those people were not professional astronomers. They were just passionate and curious. That, plus the curiosity I see in people when I talk about my work, makes me feel like part of something bigger than myself." Despite extensive study, many mysteries still surround the Great Red Spot. Astronomers don't know exactly when it formed, why it formed, or even why it is red. Keaveney and his co-authors, Gary Lachman of North Carolina State University and Timothy Dowling of the University of Louisville, focused on how smaller, transient storms affect the Great Red Spot. Using the Explicit Planetary Isentropic Coordinate (EPIC) model, they ran a series of 3D simulations of the spot. Some of these simulations included interactions with smaller storms, while others did not. The comparison showed that the presence of other storms actually strengthened the Great Red Spot, causing it to grow larger. Keaveney says, "We found through numerical simulations that by feeding the Great Red Spot a diet of smaller storms, as has been known to occur on Jupiter, we could modulate its size." The researchers based their modeling on similar high-pressure systems observed here on Earth. Known as heat domes, or blocks, these systems occur regularly and play a major role in extreme weather events like heat waves and droughts. These systems are sustained and amplified by interactions with smaller weather mechanisms, much like what happens on Jupiter. Keaveney explains, "Our study has compelling implications for weather events on Earth. Interactions with nearby weather systems have been shown to sustain and amplify heat domes, which motivated our hypothesis that similar interactions on Jupiter could sustain the Great Red Spot. In validating that hypothesis, we provide additional support to this understanding of heat domes on Earth. Further modeling might help researchers refine these findings and possibly shed light on how the Great Red Spot initially formed." Thanks for tuning in. Don't forget to subscribe to our channel for more space news and updates.